Welcome to all. The first unit deals with conducting materials. Particularly, we are going to study about the properties of conducting materials. Let us start with introduction. What is matter? Matter means any substance or any objects or any things exist in the universe is called matter. Any matter consists of atoms and molecules. When atoms are combined together, molecule is forming. Here we should know what is the basic configuration of atom. Atom consists of nucleus and electron. Nucleus having positive charge proton and neutral charge neutron. Around the nucleus, electrons are revolving. Electron has negative charge. This is the basic configuration of an atom. Next one, there are three states of matter. One is solid, second one liquid, third one gas. What is solid? Solid means it is the material in which atoms are closely packed together. Liquid means it is another material in which atoms are loosely packed. Third one is gas. It is also material in which atoms are very loosely packed. In this unit, we are going to study about solids and its properties. Particularly, we are going to study about conducting materials. Okay, here we should know one basic definition, that is band gap. Band gap means it is the energy difference between valence band and conduction band. We should know what is valence band and what is conduction band. Valence band means outermost energy level of an atom. Outermost electron filled energy level is called valence band. What is conduction band? Conduction band is its energy is little higher than the valence band, or in other words, it exists or it located just beyond the atom. Electron in the valence band is called valence electron. Electron in the conduction band is called conduction electron or free electron. Energy difference between valence band and conduction band is called forbidden gap or band gap energy. Again, this solid is categorized into three types: conductors, semiconductors, insulators. These categories or these types based on band gap energy. What are conductors? Conductors are the material in which band gap is very small. Conductors conduct electricity very well. So band gap is very small means this figure shows the band gap energy of conductor. Here this is the valence band, this one is conduction band. In the case of conductor, both are overlapped together. In other words, there is no energy difference between valence band and conduction band. Example for conductor, all the metals are conductors. Copper, gold, platinum, aluminum, etc. all are conducting materials. Second one, semiconductors. In the case of semiconducting material, band gap is very small. There is small energy difference between valence band and conduction band. We need to apply small amount of energy to the valence electron to excite from its valence band to conduction band. Example for semiconductor, silicon, germanium, gallium arsenide, indium phosphide, etc. Third one is insulators. In the case of insulators, energy difference is large. That is, band gap energy value is large. Energy difference between conduction band and valence band is higher or greater. If you apply high amount of electrical energy to the valence electron in the valence electron cannot able to jump from its valence band to conduction band. So example for insulators are wood, plastic, etc. In this unit, particularly we are going to study about conducting material. Whenever we are saying conductors, we should keep it in mind that both valence band and conduction band are overlapped together. All the valence electron act as conduction electron or free electron. Here all valence electron act as free electron. We know these free electrons are the responsible for carrying electricity by the material. This table shows valence electrons of few elements. Hydrogen H, its electronic configuration 1s1. So in its outer orbit it has 1 electron. Helium, in its outer orbit it has 2 electrons. Similarly, lithium, beryllium, boron, carbon. In the case of nitrogen, electronic configuration is 1s2, 2s2, 2p3. So 2s is the outer cell. So the outer cell having 5 electrons. So number of valence electron for N is, nitrogen is 5. Similarly, oxygen having valence electron 6, fluorine has valence electron 7, neon has valence electron 8. So these are all valence electron or electron in the outermost orbit in an atom. Okay. Before we study about conducting materials, we should know some basic definitions about the conducting materials. First definition is drift velocity. Drift velocity is defined as average velocity of electron in the presence of electric field. Or in other words, drift velocity is defined as average velocity of electron per unit applied electric field. This is called drift velocity. It is mathematically represented as Vd. Next definition is mobility. Mobility is defined as drift velocity per unit electric field. That is, drift velocity of electron in metal per unit applied electric field is called mobility of electron. Mathematically, it is represented by Vd by E, where D is subscript. Next one, mean free path. Mean free path means average distance travelled by electron between two successive collisions is called mean free path. Average distance travelled by electron between two successive collisions is called mean free path. Next definition is mean collision time. Another name, collision time. What is collision time? It is time taken by free electron between two successive collisions. Is called collision time. Tau c is used to represent collision time. This is tau c. That is, collision time means time taken by free electron between two successive collisions. Next one, relaxation time. Relaxation time is represented by T. It is the time taken by free electron to reach its equilibrium position from the disturbed position when the electric field is applied. Relaxation time is defined as time taken by electron to reach its equilibrium position from the disturbed position when the electric field is applied to metal. This is called relaxation time. Then we know the definition for band gap. Band gap is nothing but it is the energy difference between valence band and conduction band. Another definition is, this is the exact definition, energy difference between minimum energy of conduction band and maximum energy of valence band. This is called band gap energy. Here we are also using another term, that is current density, which is represented by J. Current density is defined as current flowing per unit area of metal. Current flowing across unit area of metal is called current density. Mathematically, it is written as I by A, ampere per meter square. With these basic definitions, let us study with this basic definition, let us discuss the postulates of classical free electron theory. Classical free electron theory is the first theory. This theory is proposed only for metals or conductors. This theory is also called as Drude-Lorentz theory. Drude-Lorentz theory of metal. Let us discuss its postulates. The postulate number 1 is metal consists of atoms. Atoms having nucleus and electrons electrons are revolving around the nucleus. This is the first postulate. First one is metal consists of atoms, atom having nucleus and electron. This is the first postulate. Second postulate is valence electrons are free to move about the whole volume of metal. Valence electrons are free electron. These free electrons are moving about the whole volume of metal. All the valence electrons are called as conduction electron or free electron or electron cloud in conducting materials. This figure shows atom. This red color dot indicates nucleus. This blue color rings. These blue color rings shows the electron cloud. Third postulate is in the absence of electric field, electrons are moving in random direction. This is the third postulate. Fourth one is in the presence of electric field or when you apply electric field to the metal, free electrons in the metal are accelerated in the opposite direction of electric field. So these electrons are accelerated with the velocity. That velocity is called drift velocity. Fourth point is in the presence of electric field, free electrons in the metal are accelerated in the opposite direction of electric field. So these velocity of this accelerated electron is equal to drift velocity or average velocity. Fifth postulate is electron velocities obey Maxwell-Boltzmann distribution function. We know f of E represent Maxwell-Boltzmann distribution function. So this mathematically this function is represented by f of E equal to a into e power minus e by kt, where f of E is called Maxwell-Boltzmann function. What is the physical meaning of this function? It represents the position of particle. In other words, probability of finding the particle with the energy E is f of E, which is equal to a, where a is normalization constant and into e power minus e by kt, where e is energy of particular energy level, k is Boltzmann constant, t is temperature of system. Then the sixth postulate is electrons are negatively charged particles and the positively charged particles are considered to be immobile. What is the sixth point? Electrons are negatively charged particle and the positively charged particles are considered to immobile. These are all the six postulates of classical free electron theory. This classical free electron theory having few merits and also this theory also having few demerits also. First, let us discuss about few merits of classical free electron theory. This theory is used to verify Ohm's law. We know Ohm's law, V equal to IR. Voltage drop across the metal equal to current flowing in the metal into resistance exist in the metal. This classical free electron theory is used to explain electrical conductivity and thermal conductivity of metal. This theory is used to explain optical properties of metal. To explain Weidmann-Franz law. We should know here what is Weidmann-Franz law. Weidmann-Franz law states that ratio of thermal conductivity K to electrical conductivity of metal, which is equal to L into T. Ratio of thermal conductivity to electrical conductivity equal to L into T, where L is called Lorentz number, T is called temperature of the system. So these are all merits of classical free electron theory. This theory also having few demerits. The demerits are this theory fails to explain the phenomenon like photoelectric effect, Compton effect, blackbody radiation and thermionic emission. This theory cannot explain the electrical conductivity of semiconductors and insulators. This theory only explains the electrical conductivity of metals. Moreover, this theory fails to explain the ferromagnetic property of the material.